Hello everyone, today we're going to talk about composition of functions. And in real world situations sometimes, it is not uncommon for the output of one function to depend on some input that is itself the output of another function. Okay, and this is a composition type of situation. All right, you're literally taking the result of one function and plugging that result into another function. Okay? There is a new symbol that you're going to start seeing. It's this open circle right here. And so we read this. This is read as f of g of x. That's how you read it. F of g of x. Now, we work from the inside out in our function. So we're actually going to calculate the g of x part first, and whatever that result is going to be plugged into the next function in line. And you could have several functions. You could have f of g of h of x, and that would be three functions. Okay, so let's take a look at a few of the examples down here. We've got two functions. I've got a linear function and I've got a quadratic function. So we're just going to run the gauntlet of what we could possibly do here. All right, so for this first one, just f of g of x, it means that we are going to take the g function and we are going to plug it into the f function. So we're going to take all of this and we're going to substitute it into the other function everywhere there's an x. And so that's going to look like this. We'll take 2, and not x, not 2x, but 2 of the function g's, so x squared minus 3x plus 8, and then minus 5. So that's the rest of the f function. And then we're just going to simplify it. So we'll distribute through the parentheses. We'll get 2x squared. We'll get minus 6x. We'll get plus 16. And then we also have that minus 5 tagging on the end, all right? So what can we do here at the very end? We can combine those like terms. All right, so we'll get 2x squared minus 6x plus 11. All right, let's keep that in mind. Now, what happens if we reverse the order in which we substitute, right? Instead of taking all of the g function and plugging it into f, what if we were to take all of the f function and plug it into g? That's going to look a lot different. All right, so what I'm going to do, I'm going to see if I can't, let's see, can I? I'm going to take this, I'm going to put it right here, and we're going to redo this problem, but we're going to do it in the other order. All right, so now we're going to do g of f of x, which means, let's see if I can write it out here, we are going to take the entire f function and we're going to substitute it into the other one. All right, so what's that going to look like? That will be not x squared, but 2x minus 5 squared. And then not minus 3x, it's going to be minus 2x minus 5. And then plus the 8. So we've taken the 2x minus 5 part and we've substituted it everywhere there's an x in the other function. And this is going to be a little bit tougher, right? Because what do we do when we square it? We have to FOIL it out. And you may have to go do that FOIL work somewhere else. So let's flip the page real quick. 2x minus 5. And we are going to FOIL 2x minus 5 squared. So that is the same thing as 2x minus 5 times 2x minus 5. And that's just first times first, 4x squared. Then we have the outside pair, which is negative 10x. And then we have the inside pair, which is also negative 10x. And then we have the last pair here, which is positive 25, right? And look what we can do. We can combine these middle terms, and the result is 4x squared minus 20x plus 25. All right, so that's what we're supposed to get when we FOIL this out. Let's go ahead and copy this, And let's take it back to our other problem here. All right. So right here, we got that when we FOILed that part. But now we're going to have to distribute on this next one. All right, so that's going to give me negative 6x and positive 15 when we distribute. And then we still have that plus 18 hanging on the end. So I've kind of stacked mine here so that we can see which are the like terms. Okay? And so let's go ahead and combine all of our like terms. We've got 4x squared. We've got negative 26x's. And then, I'm going to have to grab my calculator for all that. Let's see, 25, 15, well that should be, 25 and 15 is 40. 40 and 18 is 58. I guess I can do that in my head. 58. That is completely different than the first one we got, isn't it? So reversing the order is going to change the outcome. All right, changing the outcome, so they're not the same. Right, that's different, right? When we did algebra of functions, f plus g and g plus f were exactly the same. F times g and g times f were exactly the same. The subtraction wasn't, right? Those are not the same. And what else? The division one was not the same. Okay? And composition isn't the same either. Right? They're completely different answers. Okay, what's next here? Let's see what we got. Same two functions. Let's see what we have next. We are going to substitute 7 for the x. All right? So this first one here, f of g of 7 is telling us to plug in g of 7 into whatever that result is, plug it in to the other one. So we need to calculate g of 7. So that would be 7 squared minus 3 times 7 plus 8, right? 7 squared is 49. 3 times 7 is 21. And let's see, 49 minus 21 is 28. 28 plus 8. 28 plus 8 is 36. So we have f of 36, right? This part right here turned out to be 36. And that's what we're going to plug in to the next function. F of 36 is 2 times 36 minus 5. All right, so 2 times 36 is 72 minus 5, and that would be 67. Okay, do you think we're going to get 67 if we plug in the other direction? No, we are not. Let's go ahead and move this one over here. That's 67. And let's start over and do the other composition. All right, this time we're going to go in the other direction. G of f of 7. So that means we want to find f of 7 first and plug it into the other function. So f of 7 is 2 times 7 minus 5. That's 14 minus 5 is 9. So really what we want to find is g of 9. All right, g of 9 is 9 squared minus 3 times 9 plus 8. So 9 squared is 81. 3 times 9 is 27. And 8 more. I'm going to go ahead and use my calculator on this one. 81 minus 27 plus 8 comes out to be 62. See, that's a completely different answer. Changing the order changes the answer. All right. Now let's try some other ones. These next pair are called recursives. Recursive is where you're just plugging it into itself. All right, so this first one here is having us calculate f of 1. So we're going to calculate f of 1, which is 2 times 1 minus 5. So 2 minus 5 is negative 3. And so now we have to do f of negative 3. So now we're going to plug in negative 3 there, which gives us 2 times negative 3 minus 5. So negative 6 minus 5 is negative 11. Okay, see how that works? That is a recursive. You take your answer, you play it right back into the same function. All right? Let's try the other one. Let's try the other one. That one is g of 1. So we're going to calculate g of 1 to start with. Do that up here. 1 squared minus 3 times 1. Oops, getting a little sloppy. Let me try that again. 1 squared minus 3 times 1 plus 8. So 1 squared is 1. 1 minus 3 is negative 2. Negative 2 plus 8 is 6. So this part is 6. And now we have to calculate g of 6. So now we're going to go through the g function again. That's going to be 6 squared minus 3 times 6 plus 8. And 6 squared is 36. 3 times 8 is 3 times 6 is 18. And add 8 to that. So basically we have 36 minus 10, or we have 26. Okay? So that's pretty easy, right? Recursive functions, just plugging it back into itself. All right, let's see what we have next. F of x. That means we're going to start with the f function, and we're going to plug in itself. So that gives us 2 times itself, 2x minus 5, and then minus 5. That's 2 x's, and our x in this case is 2x minus 5. All right, so we're going to distribute 4x minus 10 minus 5, which is 4x minus 15. All right, now let's do the other one. Ooh, the other one's going to be tough because we are going to have to plug this quadratic equation into itself. G of x squared minus 3x plus 8. Okay, so that means the x squared part is x squared minus 3x plus 8. And then you have minus 3 times the x part, which was x squared minus 3x plus 8. And then you have plus 8. So, I'm not going to finish this one. This one is tough. You are going to have to multiply. I'll show you what it's talking about. This first part here is trying to multiply the trinomial times the trinomial. So the trinomial times the trinomial. That is beyond FOIL because you have this first term times all 3 of the other parts. And then you have the middle part times all 3 of the other parts. And then you have the last term times all 3 of the other parts. So you have to do 9 multiplications there for this. And then you have the rest of it to go. I guess we can do this. Let's go ahead and do it. All right, the x squared times x squared is x to the 4th. The x squared times negative 3x is negative 3x cubed. The x squared times the 8 is 8x squared. All right, now we do the middle term. Negative 3x times x squared is negative 3x cubed. We already had one of those. I'm going to write it below it. Negative 3x times negative 3x is positive 9x squared. We already had an x squared. I'm going to write it below it. Then we have negative 3x times 8, which is negative 24x. All right, then we have the last term. 8 times x squared is 8x squared. Then we had 8 times negative 3x, which is negative 24x. Then we had 8 times 8, which was 64. And look at all the parts we can stick together. This is why I would stack them, so you can see which ones match up easily. X to the 4th minus 6x cubed plus 17 and 8 is 25x squared minus 48x plus 64. And that's just the squared part. We still have all of the rest of this to do, right? Negative 3 times x squared is negative 3x squared. We have negative 3 times negative 3x, which is positive 9x. Then we have negative 3 times 8, which is negative 24. And we still have one more, plus 8 on the end. This is a very long problem. Can we stick anything together? Do I have any other x to the fourths in this problem? No, I don't see any x to the fourths, just that first one. Do I have any more x cubes in the problem? No, that's the only x cubed there is, 6x cubed. Do I have any more x squareds in the problem? Sure I do. I got one right there. I got 25, and I got minus 3. So 25 minus 3 is 22x squared. Then we have a regular x here with a regular x there. So negative 48 plus 9 is negative 39x when you stick those together. And now we have 64. We have minus 24. So let me grab my calculator. 64 minus 24 plus 8. That comes out to 48. Finally, we are done. I don't wish you to do that for any of your problems, but that's what that is. If you plug the g function into itself, you get something very large. Okay, hopefully this has been enough to show you how composition works. Plugging one function's result into the other function, or maybe even into itself. If you have a number in particular, you can plug that number into the first function, and whatever that result is would go into the second one. So here we would first calculate f of 7, and then we would plug our result into g and find whatever that is. Okay? If you have any questions, give me an email.